Good day, class. Today we're going to be going over the sum, difference, and product and quotient of these two equations you see here. Yesterday we had the opportunity to go ahead and practice the sum, product, and quotient of some equations were fairly more simple. Now these right here are equations that are set up as a fraction. There's a variable in the denominator. So I want to go ahead and highlight this important fact of them, because one of the first things we're going to have to do is to define the domain restrictions on these two here. This one and this one right over here. And I like to make them red because I want to go ahead and point out that these two are important because the domain restrictions that you see with the original equations are going to carry throughout until even when we combine, do the sum, difference, or product of these two equations. So let's go ahead and define or write down domain restrictions on these. So let's start with the first one, and I'll go ahead and do f of x. Now with f of x, the domain restriction on this is that x can be any number as such that it's not -2. The reason being is that if a -2, in bracket there, goes in the bottom of this denominator, that means that this becomes 0 and we don't have something that is good. This becomes 0. Well, we have something in the equation that does not exist. So we can't have that happen. Now let's go ahead and go over to the next one. Now this one over here, we're going to go ahead and also define the domain. Now on this one, the domain is going to be written as well as all real numbers such that x does not equal +1. Because if +1 came in here, we would have 0, and again, we would have an error in our domain. So, or does not exist. So those are our two domain restrictions. Now let's go ahead and move into the actual practice of doing the sum, the difference, the product, and the quotient. Let's first start with the sum. Now the sum is going to be written in these terms, so it's going to become very important for you to go ahead and be able to see this type of notation and then recognize that this notation really means this: f of x plus g of x. Once you're able to translate or decode this, it becomes simpler to solve this because now you know that you have to do a substitution. And so let's go ahead and do the substitution. Let's go ahead and write down f5 x plus 2. And I'm going to leave some space here because when we're adding these, we're going to have to do some mathematical manipulation in order to make sure they add up correctly. So I'm going to do this and write down g of x, which is x divided by x minus 1. And I have plenty of space on the right. Now, if we have two fractions, we must, in order for us to add them, we must have the same denominator. So in order for us to go ahead and actually acquire the same denominator, I'm going to use some manipulation to make that happen. That means that on this side, I'm going to go ahead and multiply top and bottom of this fraction by x minus 1. And I'm allowed to do this because x minus 1 divided by x minus 1 is 1. So in essence, I am just manipulating the equation. So I'm going to go ahead and do that. And then on the right side, I'm going to go ahead and multiply that by x plus 2 and x plus 2. And this is part of my process to achieve to be able to add them. So now let's go ahead and add them. So let me first erase what's down here. So let's go ahead and add these two together. And I'm going to make them by a common denominator. Now I'm also going to distribute because it's going to save me a little bit of time here. So let me go ahead and show you. If I go ahead and distribute, okay, I'll go ahead and get 5x minus 5. And then over here, I'm going to distribute on this side as well. So I'll get plus x squared plus 2x. Now, I'll be able to now put this all under a common denominator, which is x plus 2 and x minus 1. There's my common denominator. Now, let me go ahead and now end up the simplification. At this step, we have to go ahead and combine like terms and come up with our actual answer, which is going to be this. It's going to be f. Go ahead and write down. It's going to be f of x, so f plus g of x, because we combine both of them. And let me go ahead and circle the ones that I'm combining. There's really only two numbers that I'm combining. I'm combining the two x's. The only x's are the only ones that are like terms. So those are the two I'll be combining. So I'll end up with x squared plus 7x minus 5 is equal to x plus 2 and x minus 1. Now, in our case, the domain restrictions are going to still be similar to the two we wrote up there, because these domain restrictions, we cannot let, you can change colors here, cannot let, I'll say x, so the domain is x is all real numbers such that x cannot equal -2 and +1. I'm running a little bit out of space, so I do apologize if it didn't come out correctly, but you do see that those are the two domain restrictions. Okay, great. All right, so this is the one for sum. This is what the final answer is and our solution. Now let's go ahead and I'm going to erase this and we're going to move on to the next one, which will be the difference of these two numbers. Find the difference of these two numbers. So let me go ahead and do that. And let me come up here and erase this as well, because with this next one, the difference of two numbers, we're going to follow something of the same operation, but it's going to be slightly different. And what I'm planning to do with this one is that let me go ahead and actually show you some notes that have been pre-done. And these notes that have been pre-done will give you a good idea, because they're going to be very similar to your previous notes, but there is going to be a slight difference on how you compute this. And here it is. This is what it should look like. This is what the quotient should look like. And this, let me walk you through it so then you would understand. Now let me erase some things first, because I went ahead and pulled them out. When you're taking the quotient, okay, the first thing that I want to make sure that you all more in a sense realize is this part of it right here. And really what this is a translation of this part here, which was, would probably be written like this. Oh, actually, I jumped ahead myself. I'm showing you the quotient. I have to show you, I'm going to show you the subtraction notes on this one. So let's go ahead and go back on this. And let me erase this, and then I'll go ahead and show you what the subtraction, the product, it's this one. What does subtraction look like, the difference of them? Now, the first thing you got to make sure you keep in mind, you're seeing all these notes in front of you, is this idea. This idea that f of x really means this part here, which is the f of x minus the g of x. With that in mind, then you're able to do the substitution. And the substitution is shown here from the two equations. We have the substitution that shows up like so. Here, there's the first substitution. Here's the second one. The important thing to keep in mind is that that's minus. Now, the same steps was taken as the other one. In order to manipulate this equation, we must make a common denominator. So the only thing not shown here is this step of the notes, which shows this. We'll have 5 x plus 2. If you get a common denominator, it does x minus 1 and x minus 1 on this side, subtracted by x, and in this case I'm going to have x minus 1, x plus 2 on this side, and x plus 2 on this side. Now, once you have this next step right here should become clear as far as what we're doing. Because now, if you notice, this side, this part of it here, it's very similar to this part here. And this part here is very similar to this part here. And as you can see, the lines, they distribute. So once you distribute this, you'll get this equation right here. And the only thing, since you have different sign changes with somewhat of the same type of variables in place, your equation is going to result on slightly different type of equation it's going to be formed, which is going to be here. Now, very important, you can't forget the domain restrictions that were in place. The main restrictions for this equation are these. X such that x does not equal -2 or 1. Okay, fantastic. Now let's go ahead and move over and do the next problem. Let's go ahead and I'm excited on doing the next solution for you. And in this one, we're going to go ahead and practice product. Now, in practicing this product one, I'm going to go ahead and now restart with the original notation. So the original notation is this. This is what you're going to get accustomed to, is that f times g of x really just means f of x times g of x. So let me go ahead and now do some substitution. We'll have 5 x plus 2 times the g of x with x over x minus 1. Now, one neat thing about with this notation is that you're going to realize that and when you do a multiplication and in this kind of setup, our solution is pretty simple, because I could go ahead and erase this. Oh, that was a big erase. Hold on. Let's go back, make a correction, get a smaller eraser. No, I didn't want that. Oh, does it again. I'm not sure why. Okay, what I want to point out, and what I'm going to avoid, so it won't all just go away, is the fact that pretty much you can combine those, and these are just automatically assumed that they're being multiplied. So like in this case, I'll go ahead and then make my equation for this is almost already complete once you do the substitution, because f times g of x is really just 5 of x over x plus 2 x minus 1, and we must include the domain restrictions, and our domain restrictions are all real numbers of x such that x does not equal 2 or, oh, I'm sorry, -2 or +1. So that's how we get that. Now, let's go ahead and try the quotient. And really what I do, what I'll encourage for you to do at the moment, is go ahead and pause this video, and if you're watching on the player, you try it. Okay, take the next couple of minutes. Once you find out, or you got your answer and you're giving it a try, I want you to now, after that, I want you to press play. So, now, I'm assuming you did what I'm saying, and now we're on to the next step where you hit play. And I want to show you the quotient, because I know that some people probably saw it, got to a certain step, and got stuck. And I could know where they got stuck, because they're not used, if you're not used to working with fractions, you're probably not used to seeing this kind of manipulation. Now let me erase all this, because it looks like it's moving with it. You're not used to seeing all this. Now you also can find these notes on the web page. But let me go ahead and show you what it is that what you kind of got stuck on the quotient one on, and really how to get around it. Now go ahead and highlight. Okay, this right here is what you had to transcode on the quotient one, and what you had to know already was this idea. This is really one step ahead of this notation here. F divided by g of x is equal to that. Now, once you get to the highlighted part, we put down our two equations dividing with each other. Now this is where, if you don't understand how fractions work, once you divide two fractions, then really the bottom fraction becomes a reciprocal. What I mean by, and you'll see that this becomes a multiplication with the reciprocal of each other. So that is something you're going to have to learn if you don't feel comfortable with it already. Now, once you do that, then it does become simple, because if you can see, you take this equation, you put them together, and you got 5 multiplied by binomial on top, which is x minus 1, and a denominator of this, which will have our one new domain restriction because x cannot be 0 here as a highlighted part, and the other part right here where we find out that x can also be negative 2. Now we must also carry the domain restriction found off the original. So at some point or another, the domain could not be 1. So I want to make sure you understand that this is attributed because of original domain restriction that occurred during the transformation or before the transformation of the equation. So we find out the domain equals actually all the numbers such that x is less than or equal negative 2, 1, or 0. Okay, great. Let me go ahead. It was nice doing this sum, difference, and times for you. I'm going to go ahead and pause this, and please reference back to this. I do appreciate you watching this.